Good morning, everyone. Welcome. Let's check out 2.3 and let's see how we go. Here we go. Here we go. It's going to be great. Big shout out and big thank you to one of my friends for bringing me a TI-36 to try. They said that it's nothing like the TI-30 and that I'm going to love it. I, of course, have my Casio as a backup just in case. So we'll be checking out those calculators today, and we'll see how we go. So on 2.3, we have this problem to solve. It's x to the third plus 1 equals 0. I notice it's degree 3. And if it's degree 3 or degree 2, what you need to do is you need to factor it. So I'm saying to myself, I got my thoughts up here. If something's a binomial and I need to factor it, well, it could be a greatest common factor, it could be a difference of squares, or it could be a cube. One of those three. If it's not one of those three, then it doesn't factor. And I start thinking about it. Well, look, that got raised to the third right there, and it doesn't have a greatest common factor other than 1. So I'm like, it's a cube is what it is. Now, when it's a cube, it's a formula, and I like to sing a song. You don't have to sing a song, but if you want to sing along, you can. And so I have to identify the bases. So I put parentheses to identify the bases with raised to the third. And then I fill in, well, what raised to the third is x to the third? Well, x raised to the third is x to the third. And so I know that a video, you can't talk back at it, but I hope that I give you enough time to respond. I hope I do, that you do try to talk back at it and see. And that way you can kind of get the practice of going along. So now I'm asking you, what, when you raise it to the third, do you get 1? I hope you're thinking 1. And now this is when you whip out your song. It's going to be a binomial times a trinomial. It's going to still equal 0 over there because I have equal 0. And so I'm all finger over threes, write what I see. I should have warmed up my voice first. Me, right? So my finger over threes, write what I see. And then square, so x squared. Multiply them together, x. Square, 1 squared is 1. And then SOAP. Same as I started with, minus, opposite of that, always positive. So now I have it factored. This trinomial never will factor any further. This binomial is all done. And so remember how you solve stuff after you get it factored as fully as possible is you set the pieces to 0. So sometimes you have a monomial times a binomial. Sometimes you have a binomial times a binomial. Sometimes you have a monomial times a binomial times a binomial. In this case, for the first time, we have a binomial times a non-factorable trinomial. And so we're like, oh, okay, I'm going to set this to 0. X plus 1 equals 0, and I'm going to solve that. And then I'm going to solve x squared minus x plus 1 equals 0, and I'm going to solve that. So that's kind of my thing that I'm going to be solving. So this one I clearly can solve because it's linear. And how you solve linear equation is you use the distributive property, you combine like terms, you get the variable on one side and the numbers on the other, and then you divide to isolate the variable. In this case, the only thing I have to do is take away 1. And I have x equals negative 1. There's one of my answers, and I'm expecting 3 because it was degree 3. And here, I know that won't factor, so the choices are, now this is where I'm choosing the method, right? Well, would it, because I've got quadratic, right? And we have 4 different methods of solving a quadratic. The square root method, the factoring method, the quadratic formula method, and completing the square. And I told you that I would only use completing the square. Now that's just me. You can do you do you. I would only use completing the square if that's what the directions said to do. So that's why I have it listed last. And the directions are telling me solve any method I want. So I would say to myself, well, can I use the square root method? And I hope that you're saying no, and I hope that you're thinking why I can't. No, I can't use the square root method because of the negative x. It has no missing middle, right? No missing middle. That's the problem. It needs to have a missing middle in order to use the square root method. So it has a middle, which I've spelled wrong, but all I have to do is add an L here and I'll have it spelled right. It has no missing middle. Okay, can you factor it? Well, we already learned that that trinomial is prime. And so whenever you you can try to factor it right now, but because it came from the formula of the sum of cubes, the cube formula, we know it's prime. It won't factor. So no. So that leaves me with nothing left than the quadratic formula or completing the square. And you can complete the square. It works on all of them. So if you love it, go ahead. But I'm all here identifying the coefficients. So there's a 1 right here. So that's a equals 1. I got descending order and 0 on one side like I need for the quadratic formula. There's a 1 right here. So b equals -1. So after you get it in descending order with 0 on one side, called standard form, then you identify a, b, and c. So I'm identifying a, b, and c. And then you voom them into the formula. So x equals -b. I'm going to write out the formula. B squared minus 4ac over 2a. X equals negative of plus or minus square root of squared minus 4 parenthesis 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 2a. And I'm going to do a little plug and chugging here. So where I see b, I'm going to put -1, 2 places. Where I see a, 2 places, I'm going to put 1. And where I see c, I'm also going to be putting 1. Coincidentally, a and c are the same. And then I'm going to use this fabulous calculator to simplify it. Now, underneath my square root, I can already see, can you guys see that it's going to be negative? So if I just put that in my calculator blindly, my calculator is not right now in complex mode. And so it will say, it'll say error is what it'll say, because the underneath part is negative. And so if you want to see that, I'll show you. And so here is negative of -1. I'm going to just put plus. Remember, I told you guys you just have to put 1 when you're putting in your calculator. And then -1 squared. And minus 4 times 1 times 1 divided by 2 times 1. And so I put a lot of work into showing you that it's going to say math error. And the reason it's saying math error is not anything I did wrong. It's that underneath this square root is 1 take away 4, which is -3. Oh, I'm sorry. I'm sorry. Excuse me. So I have x equals, here is 1 plus or minus the square root of -3 over 2. Now, the calculator will handle, it when you have a negative underneath. I think it's going to erase everything I put in when I change the mode. But if I go here and I push the mode and I go to complex mode, yeah, it did. It cleared everything. Then it will do it. So if I wanted to, so because it's complex, it needed to be in complex mode. But I probably, what I like to do anyway, I guess, is I like to simplify up underneath that square root myself. I'm putting this in real quick just so that you can see that it will do it, because I did tell you it would. And so I want to prove to you that it will. And I don't know how to put the TI yet in complex mode, so I'm not using it, but I'm sure that it has it on this fancy TI. So the TI 36 Pro, it says. And so now when I do it, it does see how it did the I. There's the I, and it did the I. So if I simplify this by hand, I would be pulling out the I, right? Square root of -1 is I. So this is 1 plus or minus, I'm going to put the I in front, square root of 3 over 2. And then you notice that if I divided the pieces, 1 divided by 2, there it is, 1 divided by 2, and the square root of 3 divided by 2, I. So my calculator does it, I did it. This is good. You can leave it here. You can also write it like the calculator did. If you do write it like the calculator did, remember that the calculator can't handle the plus or minus. And so you have to remember that you put in just plus so that it can handle it. And now you need to change that to plus or minus. And so back to plus or minus there. So either way is good. We did a lovely job. I'm going to leave it just like this. Beautiful. Then the next one is solving, and I have x's in the denominator. And so it's not appropriate to talk about whether or not it's quadratic or linear or cubic because there are x's in the denominator. And so what you want to do when there are x's in the denominator is that you want to get those x's out of the denominator. This is called rational. Rational has the word ratio in it, and it means that it is a fraction. And so what you want to do is you want to multiply every term, there are 3 terms, by the common denominator. And this term x is a monomial, and this term x plus 3 is a binomial. And x plus 3 won't factor, so they don't have anything in common. So the common denominator is found simply by multiplying them together, x times x plus 3. So the LCD, lowest common denominator, is found by multiplying. You could also call it the least common multiple, x times x plus 3. They're the same guy. When you use it to multiply, to clear the fractions, people a lot of times call it the least common multiple. I don't care. They're exactly the same person. So we're going to be multiplying every piece. So we have the piece that has 1 in it. I'm going to put a box. And we have 1 in here. Equals. Then I'm going to put another box, just so I'm doing it to all terms. 2 over x. Plus. And then I'm going to put another box. The box method. Just helps me separate them. And then what I'm multiplying by on every one of these pieces is x times x plus 3. So right here I'm multiplying by x times x plus 3. Almost fits in the box, is what I was hoping. Now, this is a fraction. This it's not written as a fraction, but you can write anything as a fraction because when you multiply by a fraction, something that is not a fraction, you should make it look like a fraction. So I'm going to write this over 1 so that it looks like a fraction when I multiply it by this fraction. This pen is not exactly, it just kind of writes where it wants. It has a really big writing surface. And so you notice I almost crossed that out, but I was trying to make fraction. And the same here, this is a fraction, so I'm going to write it as a fraction. And then the reason that I multiplied by this was to clear those fractions. So here there was no fraction. So all I'm going to do is distribute and get what I get. So 1 times x is 1x. 1x times x is x squared. 1x times 3 is positive 3x. So I just get what I get over here. So that's a plus right there. I might even get my blue pen to write over it because it's right on the line. Yeah, I don't know why I have to have those boxes around things, but if I didn't, it would be a little bit better, but I just can't handle it without them. It's part of my charm. And so x divided by x right here is 1. So these x's cancel. That's the reason. You notice now I don't have a denominator. And in that numerator, I have equals here 2x, right? 2 times x, and then 2 times 3. So 2x plus 3 equals, then the x plus 3's cancel out here, leaving 2 times x. Notice nothing in the denominator on purpose, so 2 times x. So when the dust clears here, I'm noticing now it was rational when I started. Now I have no fractions, so it's not rational anymore because rational had fractions. And now I'm noticing, oh, it's degree 2, right? I'm noticing it is quadratic. That's degree 2. So I have transformed it by clearing the fraction into quadratic. And remember how you solve quadratic is that you make a decision on one of these three methods, because it doesn't say completing the square, so I'm only going to use the 3 because I only use completing the square if the directions say so. So I'm right now worried about the middle term, right? Because I love the square root method. And I notice that I have x squared plus 3x equals 2x, and 2x is 4x. And so I have middle term, and in fact, I have middle term on both sides. I just combined the middle term on that side. And so I'm going to have middle term no matter what. So can I use the square root method? And the answer is no, because I have a middle term, which is different than a middle finger. So I have a middle term. And so then I say, well, could I use factoring? Now, to use factoring, you have to have 0 on one side, and I don't have 0 on one side. And I want my leader to be positive, because standard form is your leader being positive. It'd be great. So I'm going to take away 4x, both sides. And I'm going to take away 6, both sides. I'm going to write that kind of under here, and I'm going to have x squared. They know where they go. That one goes first because it's the leader. Minus x minus 6 equals 0. And now I can do factoring if it factors. And this is one that I wouldn't mind factoring. It's only a trinomial. It doesn't have a greatest common factor. And I can think of the ways of making 6. And if I can come up with something that makes 1 in the center, then it factors. And if I can't, I'll have to use the quadratic formula. So I'm thinking x times x. Remember, this is a 1. And I'm thinking 1 times 6, and I want it to subtract to be 1. And I hope that you're screaming at your computer right now. 2 and 3 is what I hope you're screaming. And so 2 and 3 also multiply together to give 6. But when I subtract them, because this is a subtract, when I subtract them, I do get 1. So that tells me that the signs are 1 negative and 1 plus. And now I've just got to figure out which one would be which so that I make negative 1 when I add them together, when I combine them. So that means I want the bigger number to be negative. And the bigger number there's negative is 3. So negative 3 and plus 2. And so I get x plus 2, x minus 3 equals 0. And I hope that you were 10 seconds ahead of me on getting that factored, because that's where we need our factoring to be. 15 seconds ahead of me is where we need it. And now I have made it into a binomial times a binomial equals 0. And so I can just set the two binomials to 0 and solve. And so at this point that I use this 0 principle here. So this is or. Oh, I forgot up here to say my answer. I'm going to do that before I go away from this page. Don't let me forget. And so I've turned this into linear. So I didn't kind of like circle my answer, and I'm going to do that. So this is now turned into 2 linears for me to solve, which I can solve easily by getting them separated. Adding 3. Okay. So he did a lovely job on that. And I meant to kind of clean up my answer here. Why I didn't was I ran out of room. And so that made me, got me all kind of in a bunch. But my final answer here is x equals negative 1, comma, x equals 1 plus or minus I square root of 3 over 2. So there's my final answer there. There's actually 3 answers there. One nice, lovely answer, and then 1 plus I square root of 3 over 2. That's one answer more. So that's 2 answers altogether. And 1 minus square root of 3 over 2. That's the third answer. Okay, so we did a lovely job on that. It was hot diggity dog. People are cheering. Oh man, I love math. That's what they're saying. So I'm trying to solve this one. X to the 4th minus 17 x to the 2nd plus 16 equals 0. And I'm noticing, I hope that you're noticing with me, that it's degree 4. And so if you can, if it's possible, gotta get a drink of water. If it's possible to factor it, you should get 0 on one side and factor it. If it's possible. If it's not possible, then don't. So how you factor it is you look for a greatest common factor, and there isn't one. Darn, you say. And then the next thing you do is that you try to make the first work, because it's a trinomial. And when I split this apart, x squared times x squared, that means that when I multiply them together, I'm going to get x fourth. But on the outer and the inner, I'm going to end up with an x squared on both of them. Now, if I split it apart, I'm going to show you, into x times x to the 3rd, which also makes x to the 4th, then that means when you FOIL it, on the middle, on the outer and the inner, you will end up with an x term and an x to the 3rd term. which won't be what I wanted because I wanted x to the second on the middle. So that's the reason I've got to split them. Will it always work? And the answer is no, it won't always work. And so I just hope it works. And so on this one, it's looking possible, right? At least the variables are behaving to give the first and will still give what I wanted for the variable in the middle. Now I want to know, are the numbers behaving so that I can get 16 on the last and still get 17 on the middle? The variable x squared is already working with the front because I'm unfoiling. Remember, there's 4 pieces to this, right? And we're working on the outer and the inner, and the outer and the inner are a combination of the first and the last. And the first is going to provide the x to the second, and the last is going to provide the what and the what. I hope that you're saying 1 and 16, because those definitely add to be 17. They both got to be negative. So this is x squared minus 1 times x squared minus 16 equals 0. And yeah, I got it factored, but I'm not done factoring it yet. I factored it now into a binomial times a binomial. And I don't know if you remember, but on binomials, I asked myself, is there a greatest common factor? Well, I'd already knew there wasn't a greatest common factor for the trinomial. So now, do I have any difference of squares? So I hope that you're seeing difference of squares. Both of them, I have 2 difference of squares. That's hot diggity dog that I have 2 difference of squares. If I didn't have 2 difference of squares, I'd do something different. And so, not with this factoring, but next, I would use instead the square root to solve it. So now I can factor this because it's difference of squares. It's x. Remember, you add them, x plus 1, x minus 1. You do the next one. Get ahead of me. What is it? If you're not sure what it is, then I really, 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 really recommend getting tutoring, getting help. And there's all kinds of places that you can get help for free on campus. And so now I can set the pieces to 0 and solve each piece. So it started off degree 4, which told me, hey, might be 4 solutions, right? And now I've made it into 4 linear equations by using factoring. Oops. That's why I do math in pencil, so that I can erase. And so I've seen some quizzes come completely cross out because they've written in pen everywhere. And if you want to write in pen, I'm not in favor of it, but if you want to write in pen, you need whiteout is what you need. And so that you can make your work look like college level work, because this is a college level math class. So if you were in intermediate algebra, then maybe that's okay. But college algebra is a college level math class, and your work should look like college level work. And so a bunch of crosses outs and whatnot is not college level looking work. Okay, so we're going to take away 1 here, both sides, and we get x equals negative 1. Here we're going to add 1, and we get x equals 1. We're going to take away 4, and we get x equals negative 4. And we get, last but not least, adding 4, we get x equals 4. So there are our 4 solutions. And I've been lazily not checking them this morning, and I don't know why I haven't checked any of them. Maybe at the end of the video, I'll go and check all of them, because that would be what I would recommend at the end of your test, that you would go and check all of them. So I'm going to make a note to myself at the end of the video to go and check all of them. And then I have a lot of just a reminder on how to solve radical equations, ones that have square root in them. And I've put more information than you need. Too much information, because I can't help it. I just can't help but be excited and want to tell you everything there is to know. Whenever you're solving something that is got a radical in it, if it's got even index, you have to be careful, because you can come up with what's called extraneous solutions if you're not. And so the radical was defined to be non-negative. So you want to isolate the radical on one side, and if you have a non-negative, then you can go on to squaring both sides or raising both sides to the 4th and solve it normally. And you should always check your answer when you have a root. There's extraneous solutions, so by doing nothing wrong, you could still get the you could get an answer that's really not the answer. That's what extraneous means, is that it's extra. Extraneous has that word extra in it. And so it's a solution that doesn't solve the original. It solves something along the way, but not the original. If you have your radical equals a negative and you had even root, then there's no solution and you can just quit if you notice that. Now, if you don't notice that and you go on, when you check it, then you'll know, yeah, that didn't work. And then if your radical equals a variable, you can go on and square both sides or raise both sides to the fourth or whatever you need to do, but you need to check. You need to make sure you check. If you got odd root, everything's good. You don't even have to pay attention to what you got. Just raise both, get the radical on one side and the number on the other, or the variable on the other, whatever you got. Get the radical separated and then raise both sides to the third, raise both sides to the fifth, whatever. And it'll work. It'll solve it. It won't be extraneous. If you haven't made a mistake, it's still good. I did check just in case you make a mistake. So I wish I wouldn't have had this example on here. And the reason is you're going to see it right here. And so I won't be able to help myself but make another example. So take away 6 from both sides to get the radical all by itself. So I notice that it's got a radical. And in fact, it's an even radical. A lot of times I would even call that an even root. You can call it either. So even radical or an even root. And then that tells me whenever, this is what it says in my head, be careful. Whenever you have an even root, be careful, must check. That's what I say to myself every time I have an even root because of the extraneous solution. So I'm getting the radical all by itself. I need to take away 6 both sides. I might have to turn on the fan. I'm getting so excited in here and it's really hot today and it's really hot in this room. So I'm going to turn on the fan, but 7 take away 6 is 1. And then the next thing I'm going to do is I'm going to square both sides to get rid of that square root. Hopefully the fan starts cooling this room off enough that everything starts flying. And so I'm going to square both sides. My papers start flying. You guys are saying our classroom's really cold. So square both sides. Do it on both sides. This is why I said this is not a good problem and I might not be able to help myself. But to do another is because when I square here and I square here, do you see what 1 squared is equal to 1? So if I forgot to square both sides, right, I would still have 1 over here from not squaring both sides, but I really did. It's just that 1 squared is 1. So I wish that this example had 2, so that instead at this step, I wish, oh, you can't put I wish but so close together. I wish it had been the square root of y plus 4 equals, say, I was making 2, but then there's a 4 under there. So now I'm making 3. Equals 3. So that when we squared both sides, y plus 4 squared and 3 squared, we had y plus 4 equals 9, just so that we could feel like that we squared both sides and something happened. I wish that's what I had there, but I didn't. So now I'm going to solve for y, right? Take away 4 both sides. And I get y equals -3. And remember, be careful, must check. And so I'm going to put back in the original and I'm going to check it and make sure that it checks. So here I am checking it just to make sure. I'm going to cross this out because that's just what I was wishing I had, you know what I mean? And but I showed you why I wish that is because I didn't want you to think that I didn't do something, that, oh, well, you just bring down the same 1. No, I squared it, but 1 squared is 1. So, wah on that. Okay, so square root here, and this is y is -3. Remember how I put the parentheses? I almost forgot to do that. And it's kind of really, I'm trying to get you guys in that habit and not skipping that step. Plus 4 plus 6 equals 7. So we're putting in here -3, so that when I do -3 plus 4, you can put it in your calculator if you need to, but that's 1, right? So this is the square root of 1 plus 6 equals 7. And the square root of 1 is 1 plus 6 equals 7. So 7 equals 7. I was helping someone and they said to me, I thought you had to have 0 on both sides for it to be the solution. And that's not true. You need to have both sides be equal. And sometimes you have 0 on one side, so the other side must be 0. But anyway, so that's kind of the story there. We have one more to do. But if you need more examples, including, I didn't do a cube root example here, but if you need more examples, they're in your textbook. You can watch all the examples that you want in your book. I really highly recommend it. Okay, so I'm noticing this, got a radical in it right here, and I'm like, oh, it's an even root. You can even call it a square root if you want. Even or a square root. You could also call it an even or a square radical. But the thing that I'm telling myself is it's a must check. I'm also telling myself, be careful. Those are the things I say to myself, right? Be careful on these. So you have to have the radical all by itself on one side of the equation. Well, it's not all by itself because of the add 3 right there. So what I'm going to do before you can square both sides is that radical has to be all by itself. It has to be isolated. Because when you square both sides, there's parentheses around the whole side. I'm going to square this, and I'm going to square this. And if you practiced all that stuff in chapter 1 about squaring this, you'll know that you do not get rid of your radical if you square that. Because when you write it twice and you use FOIL, on the outer and the inner will be a square root. And why am I squaring both sides? To get rid of the radical. And so if I do not isolate the radical, get the radical all by itself, I will not get rid of the radical. And so it's not helpful. I made something that I might be able to solve, but I'm eventually going to have to get that radical by itself. And so I've made a mess, is what I've made. And so what I want to do instead, so I'm erasing that. Erase, erase, erase. And I'm going to take away 3, both sides of the equation. Now 3 is not like terms with the x, so I'm going to write it right after the x. Right after the x when I write this. X minus 3 equals the square root of x minus 1. And then now I'm going to square both sides. Now that I've got the square root isolated, I've already told myself that I have to check and that I should be careful. So here I am squaring both sides. Square, square. Now this side over here, because of the square root, is right now, because of the square root over the whole thing, a monomial term. And when I square it, I just get what underneath the radical sign called the radicand. So I just get the radicand. Susie's over here being cute. She's my little cat, and she's thinking about getting up here and participating in the video, I notice. And she does love math, I have to admit. So on this side, I have x minus 3 squared. So whenever you have a binomial squared, you have to write it twice and then use FOIL. But this is a monomial squared. And when you square a square root, I don't know if you guys remember, but when you square a square root, whatever you had underneath here, we called it the radical, just equals the radical. So in this case, x minus 1. So over here, I wish I had given more room. I always make that note every time I write on these papers, and then I get a little bit more room. So here I have x squared, and then on the outer I have minus 3x, minus 3x again, plus 9 equals x minus 1. Make a note to myself, more room, more room. And I'm looking at that, and I'm noticing, oh, I have quadratic. So I took it, I'm just cleaning up the like term in the middle. Negative 3x minus 3x is minus 6x, right? And so I took it from a even root, that's what it was to start with, to now I'm like, oh, it's quadratic. And how you solve quadratics is you first look to see if they have a missing middle term. And I love it if they do. This one doesn't, right? Then after you check the missing middle term, then you know what? I can just blow right through this and keep going down. And so can you. And so I don't have to worry about it, the box ending. Okay, I'm feeling a little better. Then you want to, no missing middle terms, so can't use the square root method. So then I'm now hoping it'll factor. So in order to factor, you have to have 0 on one side. So I'm going to take away x, and I'm going to add 1. So that when the dust clears here, I have x squared minus 7x plus 10 equals 0. And then I'm like, well, will that factor? It's my favorite one to factor, and so because I can easily see if it does or doesn't factor quickly. And so making the first work would be x times x. Notice that will give middle term of x, which is what I need. And here, I hope that you're ahead of me, and I hope that you're screaming 2 and 5. And certainly it works. They have to both be negative. So x minus 2, x minus 5 equals 0. And now when we do the 0 property, x minus 2 equals 0, or x minus 5 equals 0, now we've turned it into two linears. And so that's kind of the strategy every time you're solving stuff, is to turn it into 2 of something you know. And so, or turn it into 3 of something you know, or 4 of something you know. Turn it into something you know, and then use your I know how to solve this method. And so we're going to add 2 to both sides. And then this is when I start to say to myself, there's my answer. But then I remember that I had written this note to myself, must check. It's a must check. Be careful on this. That means I have to check in the original. And I have to check both solutions. So I'm going to write the original down here just because we can't see it because I've gone off the screen on 2 screens. And I'm going to replace x with 2, both here. So when I do that, I get 2 equals 2 here minus 1 plus 3. So this is 2 equals, remember, you can get extraneous solutions, things that don't work even though you haven't done anything wrong. This is square root of 1 plus 3. 2 equals 1 plus 3, which is 2 equals 4. And no, it doesn't. And so that means that x equals 2 is not really a solution, and I should cross it out. You're not a solution. Okay, now my other possible solution was 5. So I'm going to put that in the original here, 5. So 5 equals square root, so now I'm putting in 5. 5 minus 1 plus 3, which is 4. So 5 equals the square root of 4 plus 3. And the square root of 4 is 2. So 5 equals, of course you can do your calculator, plus 3. And so 5 equals 5, and it did work. And so both sides are equal to one another. And coincidentally, they're both sides are equal to 5. That's a coincidence of this problem. So x equals 5 is a good solution. And that's a good way that you would put it. You wouldn't mention anything on your answer line, if there was an answer line. You wouldn't mention anything about 2, because 2 is not a solution. Just like 7's not a solution, and I'm not telling people that 7's not a solution here as well. You just tell people about the solutions. So that's the end of the solving in here, but I was going to go back and check. So if you're interested in seeing me try to jam a check in here, I am going to do that. And so this was the first equation right here. In order to check it, I have to have my calculator in complex mode, and I already had put this calculator in complex mode. And so we're going to check. So first I'm going to check x equals negative 1. And remember, this is looking like this. What cubed plus 1 equals 0? And what I want to put right in here is negative 1. So this is going to be, turn it on, parentheses, and then negative 1 raised to the third, and I want that to equal, when I add 1, I want that to equal 0. So when I do that, I get 0. So I know that's a good solution. Now the other two solutions, I'm going to check them one at a time. And the other two solutions, one of them was x equals, I know you can't see what I'm writing here, but I'll move it up so that you can. X equals 1 plus I square root of 3 over 2, and I'm going to put that in. So I'm going to go in here, I'm going to go up here so I can edit it, and back up along here, and where I have that -1 right there, I'm going to delete it out, and I'm going to put this fraction. So I'm going to put the fraction, and then I'm going to put 1 plus, and then I want I, and I is right there, and it's red on this calculator, so I have to use the alpha. So I push the alpha key and then that I, and I didn't do it. Oh, maybe I didn't need the alpha key. I'll see when I do the next one if I needed the alpha key. Square root of 3, just the I. It's actually black and not red, so I think I didn't need the alpha key, and I pushed it. It didn't mess me up or anything, but I think what I needed to do was just push it, because when you're in complex mode, then I think you're allowed to push that. Otherwise, it'll mean something else. And then I'm going to put the 2 in the denominator. So I have put in what I have here, right? Raised to the third equal plus 1, and I'm expecting that to equal 0. And it took the calculator a second, but it said, yeah, it is equal to 0. And then I can go back up, and remember I wanted to check also, there were 3 solutions. X equals 1 minus I square root of 3 over 2. And so I really wanted a subtract in here as well. So I can edit. I got right there, and I'm going to delete over that and put my minus and hit equals, and I also get 0. So all 3 of those worked. That was the first one that we did. And then the second one that we did, I should have checked it as well. And so we're going to check it and make sure on it. So this is the second one, and I'm checking. And I should have checked it, because it's a rational, and it can have, rationals can have extraneous solutions too. So I should have said that this was a must check as well. And so, and I don't know, it was early. It's early this morning. You don't know what time it is, but it's early. So anyway, okay, so I'm going to check these one at a time. X equals -2. And of course, I'm putting in this side of the equation is what I'm putting in. And I'm just going to fill in what I'm going to put in my calculator. 2 over, there's only x down there, so I don't have to put parentheses -2, but if I did, it wouldn't be wrong. And here I don't have to put parentheses -2 plus 3. And I'm expecting that that should equal 1, right? 1, because this is what this side over here equals. So I'm going to put this in. So I have the fraction 2 over, and then I did use parentheses so on there, so I'm going to put them here, although they're not necessary. And then the fraction 2, and then downstairs -2 into parentheses plus 3, right? So now I have put this side in just like I see it, and I want to know, am I going to get 1? If I had a variable on the other side, then I'd have to write down what I got, right? So I'm kind of asking myself, does this equal 1? Question mark. And if it does, then hot diggity dog, that's a solution. And you can see that it did. It equaled 1. And 3, x equals 3. So now I'm going to go, and where I put those parentheses, it's really helpful, because now I'm going to fill in those parentheses with 3. And I wouldn't be confused about any other 2, because even though there was other 2's up there, because I'm replacing the -2's with 3, but I'm really replacing what's inside the parentheses with 3. So I'm backing up over the -2, and I'm putting in 3, and I'm asking myself, hey, when I put this in with instead 3, right, do I also get 1? Question mark. And I hit equals, and I do. If you tried any other thing, so that means these are good solutions. If you tried any other thing, like if you tried 4, and it gives you something other than 1. If you tried 0, when I try 0, can you see what's gonna happen when I try 0? I'm gonna get math error, because you can't divide by 0, right? And so anyway, so there's that story. You got to check. Did I have another one that it was a must check that I didn't check? And I said I was going to check. Yep, one more, because I said I was going to check them all. And so now I'm checking this one. And what I'm putting in my calculator is what to the fourth minus 17 times what to the second plus 16. And I'm expecting, and so you can see why the student thought it always should be 0. And I'm out of room here, but I've extended it by putting another piece of paper underneath, equals 0. And I'm going to put these solutions in one at a time. So you can see why they said, I thought it always had to be 0, because a lot of times it is 0, but not always. And so parentheses, I'm going to check -1 first, because it comes first. So -1 raised to the fourth. Without parentheses, you would get it wrong. You would say it didn't work. So parentheses here are the very, very, very necessary. And so so we got 0. So we know that -1 was good. Now I'm going to go back and I'm going to edit that. And I'm just going to take out the negative, and I'm checking 1. So I get 0. Then I'm going to be over here, and I'm going to check -4. And I get 0. And then I'm going to check +4. And I also get 0. So all 4 of them worked. So all 4 worked. And I expected that all 4 worked, because this was, unless you made a mistake, all 4 will work. When you have to check and be careful is when you have a root, an even root like this one was, and whenever you have a rational. And I had written that out here, that you had to check it in the original. And then I don't know why I didn't. I said, well, it's because I started talking about checking them and said that I would go and check them at the end. That's the reason. Okay, so I'll at least give myself a reason. So that is the end of 2.3. And there's more videos in the classroom. Are you going to come out here, Susie, and make an appearance? Nope, no Susie. So she says, nope, nope, nope. I'm just sitting here watching the hummingbirds. And so I'll see you guys later on. Stop recording.